So let's get through this quickly. There's three major parts to this test. First part's law of sines, cosine. Second part is vectors. Third part is polar coordinates. So my first thing is, hey, how do you know when to use law of sines, law of cosines? I got that question a lot yesterday. What was my answer? Check the notes. Why? Because I freaking taught you. And if you don't remember which one's which, whose problem is that? Caden's. I blame Caden. Okay? The solution is if you have the angle side angle or angle angle side setup, essentially if you have two angles and a side, you use law of sines because you can always find a third angle given two. There's only one other case where you can't use law of sines, and that's the side-to-side angle setup. Okay? But that can be an ambiguous case, which we'll talk about. The other cases, side, angle side, are law of cosines exclusively. But if you don't want to remember that, that's 5 things to remember, right? How many digits are your phone numbers? How many digits? Anastar, how many digits is your phone number?
7.
10. 10 digits. 3 plus 3 plus 4, right? Okay. Anastar, do you remember all 10 of those digits in the specific order that they're in? Okay. Then you can probably remember 5 things if you can remember 10 things, right? Yeah, you can.
Oh, I got questions by
Yeah, no, me too.
Okay. My point is, if you do not want to remember 5 things for this test, if that just fills up your memory banks too much, then try law of sines first. You can tell when it doesn't work, right? How can you tell when law of sines won't work? What do you have to use law of sines? You have to have at least one of the A's, B's, or C's where you know both of them. Okay? Because if you don't, then when you go out to do this problem, you're going to have 2 variables, right? For example, if you look at number 1, you know the A's on that one, right? And we know big B. So when we set up our triangle here, which I'll just draw one like this. And you should draw a triangle if you don't, and you don't know what you're doing, and you come ask me for help. That's what I'm going to say. Draw a triangle, and if you don't know what I mean, then this is just tough luck. Actually, you're not going to ask me for help because I'm not even going to be here. So, yeah, you just got to do it. Now, so from there, you can just kind of like, hey, this is what I know about this. Where is my colors? Gosh, stupid. Hold on, technical difficulties. Jesus. Okay, you know what? I'm just going to do it like this, okay? You guys cool with that? Well, you're going to be. Okay. I'm going to use a red pen. I'm going to do 25, 12, 60. So I can find side B using law of sines here because I know that sine of A over A is equal to sine of B over B. Now you might be thinking, yeah, but how are you going to find the C's? Don't you need at least one of the C's to find the other C? You'd be correct in assuming that, right? How are you going to find angle C? Andrea. You got it. That's called the triangle angle sum theorem, baby. That's my bread and butter. And my Tony Checheries. Okay? I'm not going to do every single bit of these questions. I'm just going to do a little bit of each one, okay? Because I think you guys could probably figure out the rest of it from there and how you're going to find this stuff. Okay. Plus, I show you how to do the problem. The key's online already, so you can find the answers there. Okay, let's move on to number 2. Number 2, we're given a, little b, little c, which looks like this. Try using law of sines here. Can you? Abby Wilkes. Can you use law of sines here? No. You're right. Why not? Oh, hit her with the follow-up. What? Don't have any angles, which means I don't have a pair of A's or B's or C's, right? And if you don't have a pair of at least one of them, what are you going to end up with? At least 2 variables. That's right. I know, Abby. Yeah. So when you don't have, again, that's just like I said, if you don't have a pair of the A's, B's, or C's, you can't use law of sines. So in this case, you're going to have to use law of cosines, which you can find A, B, or C, whichever one you want. There is one thing you want to remember. If you're looking for A, you're going to start the fraction off with A, right? All of these, I know it looks like there's 6 different law of cosine equations. There's one. There's one law of cosine equation. All 6 of these are just helping you if you don't know how to move the stuff around yourself. Right? But how we do the angle equations right here, they're all the same, which is essentially just saying if you're looking for A, you're starting with the opposite angle or the opposite side, A, and then it never appears again. So the minus the side squared, they're the sides that aren't A. The bottom of the fraction, those are the 2 sides that aren't A as well. If you're looking at B, if you're looking for angle B, same thing, start with B and then it never appears again. If you're starting at C, you're starting with C, never appears again. Okay? So here, and I think it's faster if you understand that, here we're starting with A squared, which is 9 squared, and then we will not see that 9 again. So when we do subtraction, and then the division on the bottom, we're using the other 2 sides for both of those. Again, I'm not going to do this at this point, but that's how you're going to do it. One more thing, too. If you're not using cosine inverse, then you're not finding an angle. The only way to find these angles, other than the triangle angle sum theorem, is to use the inverse function. Stop the river. Okay. Any questions there? So you use law of cosines. You're going to have to use it again to find another angle. I guess you could use law of sines to find another angle. And then you use triangle angle sum theorem to find the last one. I guess. Okay. Now, this one right here. Again, you ask yourself, can I use law of sines? Yes, you absolutely can. Why? Because we have both. Well, because it says to use the ambiguous case law of sines. But why can you use it for real if it didn't say that? There's 2 B's, right? And if you have both of the B's, you can use law of sines. But there's only one thing you can find first, which is what? The angle A. Yeah. You can find angle A using law of sines. You can't find either of the C's yet because you don't know what angle A is. So that is the first thing that you need to do. You need to say that sine of 10.58 over 30, those are my B's, is equal to sine of whatever the frick A is over 40. Cross multiply, you solve. You're going to end up with, well, I'm going to do this step too, just because I think a lot of you guys make this mistake, and well, we want to try and avoid it. You should end up with sine of A is equal to 40 times sine of 10.58 divided by 30, right? But is that your answer when you just simplify that? Why not Anna Star or Anna Petkov? Yeah, because whatever this is, that's not A, right, writer? That's sine of A. And I'm not asking you for sine of A because sine of A, when you think about a triangle, doesn't mean anything. It's not an angle, it's not a side. Okay? So you have to use sine inverse to detach the A from sine. Okay? So your angle A here is going to be sine inverse of this crap, which I think ends up being 14 point something, 14.17. I know the sign, all the signs off the top of my head. Now, this is a side-side angle setup, right? And you could tell if you looked at, this right here, where you're given B, you're given A, you're given little b. You can see you're given us angle and then two sides. Now, what we know about that one is it's not a congruency axiom, which means there doesn't just have to be one triangle that has that, which, I do give you that hint on the test as well. You're welcome, Kyra. But, naturally, that's what you guys are looking for to expect. But with the ambiguous case, that means that there doesn't have to be one triangle. There can be no triangles. There can be one triangle or there can be two triangles. Okay? If there was no triangles, what would have happened when I found A? Would have been error, right? Like what I say to Caden when he asks if I like him. Error, error. You. No, you. I'm kidding. I like you. Kind of. Okay. Now, the other two cases come from this angle here. If this angle, the angle you find, is bigger than the angle you're given, how many triangles are there? 2. And if it's smaller? 1. Good. This angle is bigger. Which means there's 2 triangles. Okay? Now, I want to make sure we all understand this. This isn't any harder than if there was one triangle. It's just you have to do it twice. Okay? Your 2 triangles, which ignore number 4, we're not going to go over that. These 2 triangles, one of them is going to use the angle that you found. We'll call it A1. What's the other one going to use? Yeah, the supplement of A1, which is 180 minus whatever A1 was, which is 165.83. Now from there, find angle C, find side C for both of them. But from there, you just do the same thing twice. Both of these triangles use the same setup. That's why we call this the ambiguous case, because both of these triangles have the same side angle progression. All right? So you're still using angle B, and side A for all of them. But the other 3 change depending on which A you're using. Okay? Any questions? No? Great. We move on. Next is vectors. Vectors, I like vectors. Why? Because they work the way you kind of want them to work for the most part, right? For example, Aubrey Lewis, what would you expect to do when you take vector u, this vector right here, and multiply it by 2? What would you want to do there? Multiply both by 2. And guess what? That's exactly how it works. That's why I like vectors, because they work the way you expect them to. Two times 2 is 4. 2 times 1 is 2. So 2 times u is 4, 2. That's exactly right. Then we look at v minus u. Now, if I were taking vector v, and subtracting u and a star, how would you expect that to work? Like, what would you expect to be in the first spot? That's exactly right. What you would expect to be in the first spot would be the difference of the first spots, which is actually how it works, okay? So it's 3 minus 2, because it's v minus u, not u minus v. Don't forget that, which is 1. The next spot is negative 3 minus 1, which is negative 4. Any questions there? 3u plus v works the same way we just talked about. Might be easier to do this in 2 steps, okay? That way you're not thinking too hard. 3 times u is 6, 3. And v is still 3, negative 3. And once you do that first step, it requires almost zero thinking, almost zero effort. But if you do it in 2 different steps, it feels a lot easier. Now you just add. So what's going to be in the first spot? That's right, 9. 6 plus 3. We all know 6 plus 3. What's going to be in the second spot? 0. You got it. Any questions there? I'm feeling brave today. Evan?
What?
Now, as far as magnitude goes, magnitude is basically just Pythagorean theorem, right? The magnitude is a square root of v1 squared plus v2 squared. Essentially saying v1 and v2 are u1 and u2. Those are just the first term in v to the second term in v, right? The first term in u, the second term in u. So don't get too confused about that formula, because it's just telling you what spot it's in, okay? So the magnitude of u here is the square root. And since u is 2, 1, it's going to be 2 squared plus 1 squared. What's 2 squared? What's 1 squared? So this is square root of 5. V, kind of same idea. We do have a negative here, so you'd want to be careful. If for some reason at this point, when you're 18, you don't know how to square negative 3, and you're using a calculator for it, it does it right. No, I know what you're talking about. I'm about to explain it. Calculators can't be wrong. And if you do it, then it's going to, you got to be careful with the calculator if you do that, okay? Because what we're doing is exactly what I showed here. Parentheses around the negative 3 squared, right? Why is it like that? Well, let me explain. Every single negative number is technically negative 1 times their positive counterpart, right? And that's pretty much how they're determined with the calculator, and that's pretty much how they're supposed to be determined by you. Negative 1 times their counterpart. Okay? What? What's up with you guys wanting to interrupt class with phone calls? Is it like really important? Okay, get out of here. Freaking high school, man. People shouldn't be calling you. Okay. Anyway, 3 squared is 9. If you do negative 3 squared like this versus negative 3 squared like this, The difference is in PEMDAS, which your calculator is always correct on, okay? Because if I treat negative 3 as negative 1 times 3, and then I square it like this, what comes first, the multiplication or the exponent? Exponent. So this becomes negative 1 times 3 times 3. Okay? That's how your calculator reads that. Where this one, what comes first, parentheses or exponents? Parentheses. So this one is seeing it as negative 1 times 3 times negative 1 times 3. Okay? It's squaring the negative 1 times 3, or negative 3. That's how your calculator is reading that. And yes, this gives you negative 9. This gives you 9. And they're both correct. You can also think of it like this. If you don't put the parentheses around here, and I'm going to do a big fat, this is not equal to. See that, Caden? Kaysen? Not equal to. If you don't put the parentheses around it, it's going to look like 3 squared minus 3 squared, right? Or plus negative 3 squared, which is minus 3 squared. What's 3 squared minus 3 squared? 0. You get what I'm saying? Those parentheses, ultra important when you're squaring a negative number. Now, personally, and I don't want to sound harsh, I think you guys should know what negative 3 squared is. Because it's negative 3 times negative 3, right? Which is positive 9. I think you should know that, but that's I'm not your, well, I guess I am your math teacher. But I'm not your elementary school math teacher. So there's that. Okay. This is square root of 18, which reduces to 3 root 2. You guys all remember how to reduce radicals? 18 is equal to 9 times 2. Square root of 9 is 3. Right? Okay. Dot product. You guys remember how to do dot product? Whenever I give the description, everyone hates it because it sounds complicated, but it's actually super easy. Dot product is the sum of the product of the corresponding elements of the vectors. What's corresponding mean, Ellie Douglas? Yeah. Not really. I'm sorry. They're in the same spots. That's what corresponding means. For example, Aubrey Lewis and Aubrey Dugan are both in corresponding seats, both sitting on the right side of their tables, right? So essentially saying, you're going to take U and V, you're going to multiply their first elements together, you're going to multiply their second elements together, and then you're going to add those products together, okay? Which sounds complicated, right? But it's not. First, start with this. Remember that U is 2, 1, and V is 3, negative 3. I'll write that here just to help us out. What's 2 times 3? 6. What's 1 times negative 3? Negative 3. And what's 6 plus negative 3? 3. It's not very bad, right? You're fine. It works. Happens that way. So you just multiply the first two terms. For first term of both vectors, I mean. Multiply the second terms of both vectors, and then add them. That's the dot product. Now, the hardest question in this part will be the angle between the vectors u and v. But if you guys have noticed, your formula sheet says the cosine of this angle is u dot v divided by the magnitude of u times the magnitude of v. Wait a minute. Me thinking for a second. Didn't we already find the dot product of u and v, and the magnitude of u, and the magnitude of v? Yeah. I essentially set you up for this question to make it so much easier, right? This question would be harder if you had to do all that all over again. So essentially, you already know what u dot v is. You already know what the magnitudes are. So now we just have to plug it in. Cosine of theta, u dot v was 3. The magnitude of u was root 5. The magnitude of v was the square root of 18, or 3 root 2. And then we can simplify that if you want. You don't have to, but you can simplify it. 3's cross out. This is 1 over root 10. If you want to rationalize, what's 1 over root 10 equal to? Root 10 over 10. Okay, you can use either one of those. I will say, probably not best to keep these separate. I honestly probably wouldn't do it this way. I would simplify as much as possible myself personally. If you do it this way, make sure you're using parentheses around the bottom. Okay, technically, fractions have hidden parentheses on the numerators and denominators. Okay, if you don't, what it's going to do is say 3 divided by root 5 times 3. But it's going to do times 3 to the whole fraction, not just the denominator. So beware of that. So root 10 over 10 is our answer, yeah? No, why not? Yeah, because when you're looking for an angle, you got to do the inverse. Root 10 over 10 is what cosine of theta is equal to. Theta is cosine inverse of root 10 over 10, which is like 71.6 degrees. Okay, that question would be much, much, much harder if I didn't set you up for it in the first part of this, okay? Okay, we keep it moving. Now, let's talk about graphing. Now we're looking at polar coordinates. So you're looking for 4 points on the polar coordinate system within the first negative rotation and the first positive rotation. That they all are different names for the same point, essentially. Okay. So what I would do first is plot. Oh, well, you have to do this first. Is plot the polar coordinate that you're given, which means, remember, you're looking at 4 pi over 3. That's going to be this angle down here, which I'm going to go ahead and draw a little arrow on the positive direction. Maybe I'll put the arrow down here. Okay. And then from the center, you're going on that line, on that angle's line, one spot. So you're going from the center to here. So this right here is the point. Every point, every name that we give is going to be referencing that same point. I think I saw some confusion on this where you thought you were doing 4 different points. You're not doing 4 different points. These should all be different names for the same point. Okay? Now, of course, we're going to be thinking about this in 2 ways. First, 2 of these points are going to be thinking about going forwards. 2 of these points are going to be thinking about going backwards. Okay? Right now, we're going forwards. We're saying our point is in the forward direction of this angle. Okay? Now we have the positive rotation angle for that, for going forwards. Now we want the negative rotation angle. How am I going to find a coterminal angle that's negative to 4 pi over 3? You subtract. You got it. Very good, Warren. You subtract 2 pi, right? Adding and subtracting 2 pi gets you a coterminal angle. It's the very first thing I taught you in this class. Isn't that lovely? And we never stopped using it, yet we forget it every time. So when you subtract 2 pi from 4 pi over 3, you can't subtract it in that form, right? You have to change it so that 2 pi has a 3 underneath it. But if you're going to change it to where 2 pi has a 3 underneath it, then you have to change the 2 part to 6. Because 6 pi over 3 is equal to 2 pi. 6 divided by 3 is 2. So we're going to subtract 6 pi over 3. And is it always going to be 6 pi over 3? No, of course not. If you have over 2, then you're going to do 4 pi over 2, because 4 divided by 2 is 2. If it's over 4, then you would subtract 8 pi over 4, because 8 divided by 2 is 2. If it was over 6, then you would subtract 12 pi over 6, because 12 divided by 6 is 2. So it just depends on what your denominator is, because you have to have a common denominator, right? So what is 4 thirds minus 6 thirds? Negative 2 thirds. So this is negative 2 pi over 3 would be the coterminal angle, okay? So if I want to look at the positive direction, which means I have a positive 1 as my radius, then I'm looking at negative 2 pi over 3. And again, that's the same angle as 4 pi over 3, just going in the opposite direction. All right, next. The next thing I'm going to do, change my color again. Sounds a nasty sneeze. But now I'm going to look at a different direction, right? Now we looked at this this line here. We said, hey, that was positive. But what would have been negative if I was looking at that line? Yeah, if I just continue this line, look, this would be a negative. So we would have a positive direction and a negative direction, right? Well, let's flip it. If I flip it, let's say instead of looking towards 4 pi over 3 as an angle, I look towards this angle, which was the negative direction of 4 pi over 3. It's going backwards from 4 pi over 3. Well, if I treated this as the positive direction, then wouldn't 4 pi over 3 all of a sudden become the negative direction? Yeah. What angle is this? It's pi over 3. So if I look towards pi over 3, how far away is my point from the center? It's still 1 away from the center, right? But it's going backwards 1. Now, I want you guys to think about that in regards to the xy axis. If I was going negative 1 in the y direction, I'd be going down, the opposite direction from up. So here, if I'm going negative 1 in the pi over 3 direction, then I'm going backwards 1 from pi over 3, which is still my green dot, right? So like I said, we're going to have 2 angles in the positive direction and 2 angles in the negative direction that we're looking at. So this is going to be negative 1 going backwards 1, looking at pi over 3. And then the next angle, I'm just going to use the same trick that I found the first angle with, which is what's coterminal to pi over 3, but negative. How do I find that, Savi? Huh? Opposite direction? No. We subtract 2 pi. Good. We subtract 2 pi, which is subtracting 6 pi over 3. Well, what's 1/3 minus 6 thirds? Negative 5 thirds. So this is negative 5 pi over 3. I told my last classes, I'm going to tell you guys this too. Next semester, day 1, they're getting an absolute metric butt ton of fractions. I'm going to just hammer them with fractions the very first day of school. Because we use them all the time, right? You guys got to know how to use them. Yeah. Nope. Yep. Now, another question I had last class, which I wanted to clarify. They're like, so you're finding 4 different points. No. These are all the same, different names for the exact same point. Okay? So there's not 4 different points. There's one single point, but 4 different names for that point. So every single one should make sense, right? Look at pi over 3, go backwards 1. That should be the green spot. Go to negative pi over 3, go backwards 1. That should be the same spot. You know what I'm saying? All 4 of them should be the same spot. Let's do it again. I think this next one's a little bit easier. So we're looking at pi over 2, which is what? What angle? Huh? 90 degrees. Very good. Straight up, right? Oh boy. It's going to be interesting grading these finals, I'll tell you that. So we're looking in this direction, okay? And then I'm saying negative 3 means go backwards from the center, looking towards that direction, 3. So going backwards from looking up would be going down. So we're going to go down 1, 2, 3. That's the point I'm going to be referencing, okay? So my first goal here would be negative 3. I always like to start off with just the coterminal, right? What's coterminal of pi over 2 but in the negative direction? Negative 3 pi over 2. Very good. We subtract 4 pi over 2 because 4 pi over 2 is equal to 2 pi. Then we think, okay, what's the opposite direction of pi over 2? What's the opposite direction of pi over 2? What's 180 degrees away? What's pi away from pi over 2? 3 pi over 2. Good. In other words, the opposite of looking straight up in a star is looking down. The opposite of up is down. Yay. I learned that from Miss Rachel and Coco Melon. I watch too much of that stuff. They sing the songs. The opposite of up is down. The opposite of happy is sad. The opposite of, I don't know. I was going to say something funny, but I can't think of anything appropriate to say. Anyway, yeah. So 3 pi over 2 will be the opposite angle of pi over 2, right? But if you notice that this is the direction I'm actually looking towards my green point. So now this is the positive direction. So I'm going positive how many units from the center? 3. You got it. So now I'm going positive 3, looking towards 3 pi over 2. And then, of course, we do the same direction, but now I'm going to use the negative angle. What's coterminal 3 pi over 2 in the negative direction? Negative pi over 2. Good. Okay. Now, as far as the conversions go, I'm not going to hit these very hard, but they're just formula work. You guys have the formulas. We've already done this week. We've learned all this, so it shouldn't be too hard. Don't forget here that x is r times cosine of theta, and y is r times sine of theta. Okay, where this is r, this is theta. So, for example, x here would be negative 2 times cosine of negative pi over 6. Well, cosine of negative pi over 6 is root 3 over 2. So it's negative 2 times root 3 over 2, which is negative root 3. And you would just do this, okay? So your point, that would be the x value of the point. You do the same thing for the y value, which I think ends up being positive 1. All right? There is one thing you want to be careful of. It's not on 7 and 8. It's on 9 and 10. The very first thing you guys should ask yourself on number 9 and 10 is what quadrant is my point in? Yeah. Number 9, my point is in quadrant 2. How do you know it's in quadrant 2? It's going left and up. Very good. The reason why it's going to be important is for the angle, okay? The radius won't matter. We're going to do x squared plus y squared equals r squared. I mean, that's just the Pythagorean theorem. That's how we can relate the radius to the coordinate pair, okay? Which, of course, again, watch out for this. That should be parentheses -2 squared. If for some reason, again, you're using a calculator, calculate -2 times -2. Equals r squared. And then, Pythagorean theorem. I'll let you guys finish that one off. But with the angle, you're doing tangent of theta is equal to y over x, which in this case is 2 over -2, or tangent of theta equals -1. But there's two angles where tangent could be -1. And this is where knowing what quadrant you're in matters. So you adjust your question to what angle can tangent be -1 in to what angle in quadrant 2 is tangent -1. And what angle is that? 3 pi over 4. Okay, so watch out. Make sure you know what quadrant you're in. Any questions? I think you guys are more than ready for the exam tomorrow. I think it's really easy. Okay, I'm really expecting good things out of you guys. Please, 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 please. Study. I mean, everything's hard if you don't study, so make sure you do study. But test is tomorrow. Then we have a full